Hi there! Today's video is going to be about using just the concepts of kinematics without a calculator to actually figure out some values. So the first question. The acceleration due to gravity is about 10 meters per second squared in Menominee. If you drop an apple off the top of the stout steam tower, how fast is it going after 3 seconds? That's the first one, and how far did it fall is the second part. So we're going to drop an apple off the top of the stout steam tower, and we're going to see how long did it take? No. How fast is it going? Jeez. How fast and how far? So we're going to drop an apple off the top of the stout steam tower. And we want to know how fast it's going after 3 seconds and how far it's fallen at 3 seconds. Now I'm going to ask you to not use a calculator for this, okay? So put it away and grab your pencil and paper. We're going to do this without calculator. So let's give it a try. Now the first thing we want to do, as always, is we want to draw a picture so we know what's going on. So we've got the steam tower and we've got a person, and we're going to drop an apple, and then it's going to fall down. Okay, and we want to know how fast, after 3 seconds, we want to know how fast is it going, which is our velocity, and we want to know how far it's fallen, so the change in distance that it has gone. All right, so with our basic kinematics, we can solve this numerically, but I want you first, for the first part of the problem, to think about what acceleration means. We're just going to use the idea of acceleration being 10 meters per second squared, and then I'm going to do downward. You can choose whatever coordinate system you want. Typically that would be negative. All right, so after 3 seconds, how fast does it fall? Let's use the definition of acceleration to figure this out. Acceleration is the change in velocity over change in time. So we drop the apple at time 0, and since we're dropping it, we start with no velocity. It's just dropped. At 1 second, how fast is it going? The definition of acceleration is how much it's changing, the change in velocity per second. So this means it changes 10 meters per second every second, which means that it's going 10 meters per second downward after 1 second. At 2 seconds, how fast is it going? Well, again, it changes by 10 meters per second every second. So here we've got 20 meters per second downward. At 3 seconds, we're going 30 meters per second downward. And that's the first part of the question. How fast was it going? And remember to stop and say, is this reasonable? So is 30 meters per second reasonable? Okay, we don't have a good sense usually of what a meter per second is, but we know miles per hour. So it's double plus a little bit to get to miles an hour. So double plus a little bit would be maybe 65 miles an hour. So this is somewhere around 65 miles per hour. Is that reasonable? That's pretty darn fast. That's pretty darn fast. So is this a reasonable bump? Well, we're ignoring air resistance. So we're saying it's in free fall. There's no air resistance at all. And yeah, that actually 3 seconds of fall, 3 seconds of just dropping. We don't see that very often. There's very few things that actually drop for 3 seconds. But this would be reasonable for that. All right, so the second part of the question was, how far has it fallen? Okay, so to figure out how far it's fallen, we want to know how far it's gone. All right, can we do this conceptually just by figuring out what delta x is? Maybe. Velocity is the change in position over change in time, so maybe we could do it. That would be one way to do it. And that would be actually a really good way for you to practice. I'm going to show you a different way to do it using the long one of our kinematics equations. 1/2 AT squared. All right, so this is the long one, and we want to know how far it's gone. We want to know what the change in position is. Well, I'm going to say this is position 0. So I'm going to say this is my origin right here where we drop it, which means that this is 0. And I also know that the initial velocity is 0. All right, so for something that's being dropped at the origin, this equation just comes down to the final position is 1/2 the acceleration times time squared. It's pretty straightforward. So at time 0, we're saying we are at position 0. At time 1 and 2 and 3, let's figure out where we are. Okay, so when it's 1 second, all right, well, okay, 1/2 times the acceleration, we're just using 10 for this one. 1/2 of 10 is 5. So this is 5t squared. That's what we're dealing with. 5 times 1 squared, you can do that in your head. That's 5 meters. Again, is that reasonable? So in 1 second, it's dropped about 16 feet. Yeah, second is a pretty long time for free fall. 2 seconds. Okay, so now we have time at 2 seconds. 5 times 2 squared. 2 squared is 4. 5 times 4 is 20 meters. And what do we have for 3 seconds? All right, 3 squared is 9. 9 times 5 is 45. 45 meters. Okay, so, that's around 45 yards. So we're talking about 150 feet or so. Is that reasonable? Well, okay, 3 seconds of free fall. 3 seconds of free fall is a really long time. You're gonna have fallen a really long way. Now the Stout Steam Tower is, if I recall, it's like 80 or 100 feet high. No, it might be higher than that. So I don't think the apple would actually stay in the air for 3 seconds. But if it was, this would be a pretty serious distance. But we're also going really fast when we get there. So we're going really fast at the end of 3 seconds because it's a long time in the air. And then we've fallen about 150 feet, which is, again, a really big distance. So there's a way to do it without using a calculator, just kind of using the idea of the acceleration, what the acceleration is, and just thinking about the basics of what this means. So we've done it, we've answered the questions, and we've checked your answer. That looks pretty good. I'll have another conceptual one for you in a minute.